All right, we're going to get started with binomial expansion. So this is what I talked about in my other video. We have seen before, like x plus 3 cubed. And we know that we have to FOIL here to get x squared plus 6x plus 9, and then distribute the x through and the 3 through. But we're going to learn a different way of doing that because not all the time are they that easy. Sometimes we see things that look like this. Y minus 2 to the 4th power. So earlier in class, we did talk about Pascal's triangle. And remember, Pascal's triangle relates to 11s. So how do they relate to 11s? What patterns did we see? We're going to talk about all these good things. First thing I'll point out to you is that this is 11 to the 0 power. And this is 11 to the 1st and 11 to the 2nd. So obviously, 1,331 is 11 to the 3rd. And 11 to the 4th, I can't really fit it, is 14,641. Now, when we get to 11 to the 5th, we have a little bit of a problem because we're not going to put 10, 10. So we actually have to take this and do 1 and 5, 0, carry the 1, 11, carry the 1. So really, 11 to the 5th power is 161,051. I know, you want to check it in your calculator. Go ahead and check, push pause, go ahead and check this in your calculator. Now that you've checked it, we're going to go ahead and use binomial expansion to complete this. So right here with y minus 2 to the 4th power, because it's to the 4th power, I'm going to look at the 4th row. So I'm going to hone in here, and we're going to look at the 4th row of Pascal's triangle, which is 1, 4, 6, 4, 1. I probably didn't leave enough room in that last one, so I'm going to have to squeeze this in a little bit. All right, with that first y, we're going to count down. 4, 3, 2, 1, 0. And I know anything to the 0 power is 1, so I usually just cancel out my zeros. My next term, as you guys can see, is the second term, which is negative 2. With the second term, we're going to count up. 0, 1, 2, 3, 4. And I always like to go ahead and put in all these plus signs because we're going to go ahead and multiply and add everything together as terms. So I put in plus signs. Now obviously that plus sign is going to change as that negative gets multiplied. So let's go ahead and find out this first term. We know anything to the 0 power is 1. 1 times y to the 4th is y to the 4th. The second term, well, negative 2 times 4 is negative 8 y to the 3rd. Nice. The third term, well, I know this is 4. 4 times 6 is 24, and I get y squared. The next term, I know this is negative 8. Negative 8 times 4 is negative 32y. And my last term, 2 to the 4th power, is 16. So notice we're taking the first term and counting up. We're taking the second term and counting down. And we have to multiply every term through by the number in Pascal's triangle that matches the 11th power. So you do have to memorize or know at least how to write Pascal's triangle. So let's go back to Pascal's triangle and let's talk about how to write this easily. Since I don't have all my 11s memorized, let's talk about how to write this easily. I know it starts with a 1, and then I have a 1, 1, so we know there's 1s all the way down it. This number 2 is 1 plus 1 added. You see how it's added? So that's where we get 1s still on the outside. These 3s are 2 and 1 added. The next section, 4, 6, 4. So notice we're adding. Now, when it gets a little bit more complicated as we go further down, hopefully you don't get anything to like the 5th, 6th, 7th, 8th power, but you never know. So we're going to continue to use Pascal's numbers. We're not going to use, we're not going to actually take 11 to the 5th power, which was what this number was. So you would actually, for the next line, I don't know if I'll be able to erase this. Yeah, I won't be able to erase it. Somehow when I start moving my work around, I can't erase it. So the next line, I'll write it back in green, would be 1, 6, 15, 20, 15, 6, 1. So just be aware that you would still use those numbers. All right, great job today on binomial expansion.